Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at Bill L. Williams Elementary, home of the Pioneers, and we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Suzy, and you can call us here for help with your homework or your assignments. In Bakersfield, call 636-4357. From San Luis Obispo or other outlying areas, you can call toll-free 1-866-636-6284. You can also email your questions to dothemath@kern.org, and you can watch us online at dothemathonline.net. You can also check us out on social media, Facebook, Instagram, Twitter, and YouTube.
All right.
Do the Math.
There you go. You know what? Happy New Year.
You too.
It's 2018. A lot of things. Did you have an enjoyable break?
I did. I moved.
Oh, you did? Oh, so you were busy.
Yes.
So did you move a great distance or kind of in the same area?
5 miles.
5 miles?
Yeah.
Well, that's kind of like almost across town in
Yeah.
Bakersfield, right?
Mm-hmm.
All right.
Southwest to northwest.
So everything is settled now or it's still
Almost.
in progress? All right. Well, you know what? I was going to mention that when you email a question or a problem to Do the Math, it would be beneficial if you email us on Monday, Tuesday, or Wednesday. That way we can address the problem, get an email reply back to you, because if you email us on Thursday, we won't see it until Tuesday, you know, when we're back in here. So by all means, email us if that's the best way for you to get a hold of us, but try to do so on a Monday, Tuesday, or Wednesday. That way we can get back to you promptly and instead of like, oh, it's been 4 days, I'm already through with that problem.
Right.
Anyway, we do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. We will be going, I believe it is 10 straight weeks all the way through until I think daylight savings time, and then we will be through for this year. So the countdown is on, the final 10 weeks for this year. We do have a very special guest in studio. We will be heading back out to Bill L. Williams Elementary School. But before we do any of that, let's first take a look at today's Math in the News. All right, so today's Math in the News, as I said, Happy New Year. It is 2018. Do you happen to do anything for New Year's? Like, do you go out New Year's Eve? Do you have New Year's parties? Anything spectacular, customs, or anything you do for New Year's?
Well, I used to go to parties, but now I stay up with my grandkids until midnight.
So you see, I don't even wait until midnight anymore. You know what? You know what? It's like 9 o'clock. It's midnight back in New York, where I'm from, and you know what? We're going to celebrate it that way. If I stay up a little later, that's fine. Any traditions or anything that you guys do for New Year's?
Well, you know, I grew up in LA, so we actually I've been to the Rose Parade.
Oh, fun.
And I like to watch that. And other than that, I just kind of am pretty lazy on New Year's Day.
Well, that's all right.
Yeah.
You know what? It's time to relax,
Right.
rejuvenate, and get ready for the new year. We have a custom where we celebrate the worst day on the first day. So, because of the German heritage, so we have a bunch of different wursts. Like knockwurst and bratwurst and liverwurst and things like that. So you have those things. So the worst day on the first day for good
That's
luck
great.
throughout the rest of the year.
Okay.
But a lot of people, would you do this? Would you go to Times Square for New Year's Eve and partake in that party? Not a little party. That's a big party down there.
I don't think so. I went to Universal Studios last Thursday, and it was so crowded that it was like this the whole time. And it would be hard for me to do that. I like to have a little space.
Well, now I think if you get down there, I think you've got to stay there in a certain area. You can't leave that area.
That makes sense.
Especially with the cold this year, it was probably pretty miserable
Yes.
being out there for that many hours. But with New Year's Eve, what do you notice about this photograph? I know I'm putting you on the spot here because you have no idea where I'm going with this at all, but
Well, I see lots of confetti and
there you
paper.
go. There you go. Lots of confetti. So that's exactly what I wanted you to be able to look at right there. So confetti celebrations, New Year's, sporting events, and things like that. Well, last night was the NCAA football championship. And it was Alabama against Georgia, and Alabama, the Crimson Tide, won the title. So there you can see the confetti, and they had shirts made up, Kings of Confetti, because they're always getting showered with confetti. You know, they've won a bunch of titles in the last few years. But anyway, congratulations to the Alabama Crimson Tide and the confetti. And the reason I brought that up is because confetti is made up of a lot of different colors of paper. And there actually is a guy in New York, in Times Square, who's been doing this for about 20 years. And he and probably, I mean, there's like a dozen people. And on the one avenue, his team is in charge of actually dumping boxes of paper. And that's where all this confetti comes from on New Year's Eve for that. But anyway, so I was like, all right, that's cool, the confetti and all that thing, tie it into New Year, the NCAA football. But here is something that I found rather interesting. If you could fold a piece of paper in half 42 times, the combined thickness would reach the moon.
I actually believe that because of exponents and powers.
Right, see, there you go, all right? Now, because somebody will look at that and go, well, you know what, you fold it 42 times, there's no way that's gonna be able to get that high, right? So let's take a look at this. I found this online, all right? So here, let the thickness of paper be X, all right? On every fold, the thickness of resulting paper will be 2 times. Therefore, for 42 folds, thickness becomes 2 to the 42nd power,
Right.
like you were talking about with exponents, times X, assuming it is 1/100th of a centimeter.
That's
Okay.
pretty thin.
Right. So they're saying is when you multiply that all out, you're going to get 439,000 kilometers. The distance is 384,000 kilometers. And that's the power of exponents and how things can grow rapidly. But I brought an expert in with us this afternoon, and she's going to help us verify whether or not this is going to be true. All right.
Okay.
So in studio with us right now, we have Julie. How are you today?
I'm good.
Why don't you let everybody know where you go to school and what grade you're in?
I'm in 6th grade and I go to school at Leo B. Hart Elementary.
Hart, home of the Hawks, correct?
Yep.
And have you been a Hawk for a long time?
3 years.
For 3 years. You like it over there? Everything good?
Yeah, I guess.
Yeah, as good as it can be, huh? All right. Now, you've been there and you're in 6th grade, so you've been pretty used to that school. So junior high is coming up next year. What is one thing that you're looking forward to when you go to your new school?
Well, I'm looking forward to meet new people because normally our school has the same people almost every year.
Yeah, same people. Yeah, you're in the elementary school. So you will meet a whole lot of new people next year in junior high. So that is one thing to look forward to. Now, what I'd like you to do is this was a regular piece of paper, all right? Now, the one thing about that is they never said what size the paper was that had to be folded 42 times, all right? And they said it was 1.01 centimeters thick, 1/100th of a centimeter. Paper is thinner
It really is thinner
than
than that?
1/100th of a centimeter.
Wow.
Because if you take a look, you get a caliper, you can measure the thickness of paper, all right? So they're saying 100 of these will make a centimeter. Okay, and I was looking it up, and it's actually a little bit thinner than that. So I'm not really sure about the fold at 42 times, you'll make it to the moon. But how many times do you think, without any machinery or anything like that, do you think you can fold a piece of paper in half?
Like around 30?
Around 30? Awesome. Let's check this out. All right, so take it. Come on up here so we can all see what's going on. All right, so you're going to fold it. All right, there's one fold. So you're folding it in half, not the same way, you're going the opposite way, right? Because some people might go, hey, you know, I keep folding it the same direction. might have an influence on it. But you folded it a different way, so there's 2 folds.
That's what I would do.
You can do it any way you want, okay? So now you folded it in half again, 3. 4.
Maybe
Now,
not
now
30.
before we keep going, you're at 4 folds, and you said your original estimate was going to be 30, right? And you may have gotten a high number because we were talking about the 42 folds going to the moon. Would you like to adjust your estimate now?
Yeah, maybe around 12.
12? Ooh, all right. You've got 4 right now. There's 5. Would you like to adjust your guess now?
Yeah, maybe around 6.
Maybe around 6, all right. So there's 5
Wait,
you're at.
7.
There's 6. You got to be pretty strong to crease that too, right? Get that. You think you can get a 7th.
That's pretty rough.
I'm gonna refold it.
So there's your 6 still. Ooh, and by
7.
manipulating it the other way, right? So you have a longer area right there. So you've got 7 folds. All right? Now, I want you to hold that and crease it well. You've got 7 folds. What I would like you to do is I'd like you to think, when you unfold that, how many different sections will there be? All right? And here's what I'm talking about, okay? If I fold it once, and I unfold the paper, I have 2 sections, right? Okay, makes sense, okay? I fold it twice, and I unfold it, how many sections will there be?
4.
4. Okay, so you following me? Okay, now I fold it 3 times. How many sections will there be?
8.
8.
Good to
Okay, so you're doing this in your head. Now I'm going to give you some other paper, and you've got a pencil there. And what I want you to do is I want you to work out how many different sections you think there will be since you have folded that piece of paper 7 times. And while Julie is working on that, we're going to head out one time right now. We're going to go out to Bill L. Williams Elementary School and visit with Marylou.
Thanks, Mike. We are live today at Bill L. Williams Elementary School, the ACES After School Program. And what do you think about folding a piece of paper 42 times?
I think it's pretty interesting.
It is. Do you think you would be able to do it, though?
I don't think so.
Okay, well, I have a special guest, obviously, so why don't you introduce yourself to everybody for us?
Hi, my name is Alondra Rodriguez, and I am in 6th grade at Bill L. Williams.
And how was your break?
It was interesting and wonderful, spending time with my family during this winter break, having a fun time. Yeah.
And are you ready to move on past into junior high next year?
Instead of scared, nervous, but I think it'll be interesting.
Yeah.
So,
And you're going to have a lot of different classes, huh? One being math.
yeah.
And we have math problems behind us. Yes?
Yes.
Okay, let's get going. So obviously in class you're doing fractions and decimals and percents. So let's do a quick review. We have a fraction, which is 25 over 100, and we're writing it as a decimal, which is 25 hundredths, and then we're going to write it as a percent, which is 25%, correct? Okay, not only are you changing fractions to decimals to percents, you're also working on adding decimals. Okay, so we're going to mix all of this with adding decimals. So I'm going to we're going to do 2 problems. Here's a quick one. So if I have this problem, 32 hundredths plus, let's do 32 hundredths plus, give me 2 numbers.
22.
22 hundredths. Explain to everybody how we're going to add those decimals.
Okay, so first you're going to add the 2 and the 2, which equals 4. And then you add the 3 and the 2, which equals 5. And then you bring down the 2 decimals, and you drop them, and then you drop the 0.
How would we read this correctly?
It would be 0.54 hundredths.
Okay, or can we read it as 50? Yeah,
54 hundredths.
54 hundredths. A lot of students read it as 0.54, which is really not the correct way. We want to use the correct terminology, correct? So there's our decimal. Now, can you tell us how we could change this decimal to a fraction?
You could just put it 54 over 100, and then that would convert it into a fraction.
Yeah, so you're simply writing it as you read it. That's why it's important to make sure we say that correctly. 54 hundredths, because the 4 is in the hundredths place value, and we wrote it exactly 54 hundredths. Now, can you tell us how to change this decimal to a percent?
You just move the decimal 2 places to the right, and then that equals 54%.
Which would make sense, because if I have 54 out of 100, because percent means per hundred, we have a 54%, which we don't want on a test, do we? No. Okay, so what we're going to be doing is we have one more problem real quick. We're going to do this real quick, okay? 3 and 12 hundredths, and we're going to add that to 4 and 12 hundredths. So quickly add that up for us. Okay, now change that to a fraction for us. And a percent. And again, you got 724% because we moved the decimal how many times?
2 places.
2 places. Okay, so everybody, you guys ready? Are your pens ready? Okay, so you have the problem, right? Here it is. You guys ready? Go ahead and write that problem on the board. They're going to be solving the problem. They're going to be solving it, adding the decimal, and then writing it as a fraction and writing it as a percent. Go ahead. And we're going to be checking their work, huh? You guys writing this? I see some pens ready to go. Okay, you go, guys. Again, solve your decimal. Then write your decimal as a fraction and as a percent. Okay, so let's walk around and see how they're doing. Okay, so you have your decimal, right? So now we got to change that to a fraction. How are you going to look at the example up there on the board to help you write it also as a fraction, okay? Do you see some right answers? Yes? Okay, now write it as a percent. How would you write that as a percent? How are we doing? Okay, once you have all three, you have your decimal, you have your fraction, you have your percent. Make sure you're checking with your group to see what you guys think. She has it right? Okay, so go ahead and explain what you did.
What I did was I added the 3 and the 2 and I got 5. Then I added the 7 and the 2 and I got 9. Then I brought down the decimal and then I added 4 and 8 and I got 12.
Okay, and then how did you change it to a fraction?
First I put the 12 there. Then I put the 95 as the numerator and then 100 as the denominator.
And how did you get your percent?
I took away the decimal and then I just added a percent.
Very good. So there you go, guys. So obviously we have 12 and 95 hundredths. We have 12 and 95 over 100. And lastly, we have 1,295%. Wouldn't you guys like to get that percent on a test? Yes. Wow. Thank you. Awesome, awesome job. All right, we're going to send it back to the studio.
That's going to be quite a bit of extra credit to get that kind of a percent on a test. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. If you're phoning in from outlying areas of Kern County as well as San Luis Obispo County, that phone number is toll free at 1-866-636-6284. If you phone in from San Luis Obispo County and we do one of your math problems on TV, you'll automatically win yourself some ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. Now, you folded the paper 7 times. Okay, so, and well, I'll hold on to it, keep it just like this for you. Why don't you head on over to the board with Suzy and write down for us and explain how you were coming up with how many sections you think will be in this piece of paper.
Okay.
So what was the first thing you did?
Well, the first thing I did was I put 2 to the 7th power.
Okay, why 2 to the 7th power? And what does that mean for kids that are just learning these exponents?
It means that you're going to multiply 2 times 2, but you're going to do that 7 times.
Okay.
So 2 times 2 times 2 times.
So using exponents to make things a little easier for you. All right, so go ahead and explain, and you've got Suzy right there.
So our first one would be 2, right? And then 4, and then it would be 8, and then
Can you explain why you didn't put 6? Because 8 is correct, but a lot of people would put 6.
it's because if you do 2 times 2 equals 4, and then 2 times 2 times 2, so that would be 4, and then you'd have to multiply that by 2. So you're kind of doubling it,
That's
which
exactly
is the
right.
same thing as multiplying, I guess.
Okay, very good.
And then it would be 16, 32. Oh. And then you'd have 64. So that's 1, 2, 3, 4, 5, 6. And then you'd have 128. So I'm thinking that it's going to be 128 folds.
Because you were doing the exponents.
Yes.
All right, so come on over here for a minute. And we're going to let Suzy erase that board right there, because we're going to go to the phones right now. And while we're taking the phone call, I'm going to have you kind of think about if there are any other ways you want to look at that problem. All right? So right now we're going to go to the phones. And Allie, how are you this afternoon? Hello, Allie.
Yeah?
You're a 7th grade student, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. Mary has 4 cakes. She divides the cake so that 12 of her friends get an equal amount.
Okay, is there any other information?
No.
Nope. So you have 4 cakes, and she's dividing it among 12 friends, not herself, right? Just 12 friends. Okay, so what do you think you would do next? So do you write it like this yet in your class? 4 divided by 12 as a fraction?
Are you still with us, Allie?
What?
Are you still with us?
Yes.
All right, so I think Suzy just wants to make sure of what the problem is and how you would approach this problem.
So would you do it as a fraction, or would you do it like this? Either way is fine. What would you prefer?
I would usually do it as regular division.
Regular division. Okay. Now, can you tell me why I put the 4 inside instead of outside?
Because it has to be, because it's the number that's going into the other one.
Well, yeah, the first number in the problem goes inside. 4 is the one that's being divided. Okay? So, how many 12s will fit into 4?
What?
How many 12s will fit into 4?
0.
Oops, I lost it.
All right, let's go back here. We'll go back.
There
I
we
think
go.
what happened was you
Okay.
hit the X
All
down
right.
at the bottom real quick.
So
there.
you're right, 0. Okay, so I'm going to keep going. Okay, and then how many 12s will fit into 40?
What?
How many 12s will fit into 40?
Into 40?
Uh-huh.
Hold up. Hold up.
So you can count by 12s. 12, 24, 36, 48.
Uh-huh.
So how many do you think will fit in there?
30. 3.
Yes, you got the 3 out there.
Okay,
Huh?
so 3 12s will fit into 40, and 3 times 12 is 36. Okay, and 40 minus 36 is 4. Okay, and then we have the same problem again. How many 12s will fit into 40?
3.
Yeah, and when you get the same problem, you're going to get the same answer. So that means this is repeating. But I kind of imagine that you don't want to say I'm going to be, each person's getting 0.3 repeating cakes. That doesn't quite make sense, does it?
Yeah.
So let's do it this way, as a fraction. Because you probably already know that division means I mean, that fraction and division are the same thing. Fraction bar and division. Did you know that already?
Yeah.
Okay, can you think of a way to simplify this? 4/12? Can you think of a number that goes into 4 and into 12?
A number that goes into 4 and into 12?
Yeah.
Let's see. 2.
2, okay. Okay, now, if you can keep going, you have to keep going. So can you think of a number that goes into 2 and into 6?
4.
No, why don't you try again? 4 doesn't go into 2. 4 is a multiple of 2. But can you think of a number that you can divide 2 and 6 by evenly? They're both even, so what number
2.
has to, what? I think you did 6 divided by 2. Let's try 2. Okay, 2 goes into both of those. Okay, and what's 2 divided by 2?
1.
1. And what's 6 divided by 2?
3.
3. So the answer is 1/3 of a cake. And let me just draw you a picture. Here's 4 cakes, right? And we're saying that each person gets 1/3. So I'm going to draw thirds. Are there enough for 12 people? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 cakes divided into 12 parts is 1/3 each. Does that make sense?
Yeah.
All right,
Great.
nicely done. Thank you for that call, Allie, and for getting us in the mood for food right there. We're going to send you home with a free meal courtesy of our friends at Chick-fil-A, so congratulations on that. Hey, we do have phone tutors available until 5:30. Now, you had said that you were going to say that there are 128 different sections on this piece of paper. So instead of doing it the way you were, can you go over and with Suzy make a table to show students another way on how to solve this? It might make it a little bit easier for students to understand.
Okay. All right. Let's try. Let me get the table started with a nice big table. And you're tall enough to reach, aren't you? Okay, so what do you think we should call our columns?
Well, we should call this one folds. So we know if you have a certain amount of folds, you have a certain amount of parts.
Okay.
And so you're going to start with one fold, and then
And when you have one fold,
you have 2 pieces.
right.
So it would be 2, right? And then you have 2 folds. So you'd have 4 pieces and 3 folds. So you might think that it would be like 2, 4, 6, 8, but actually no, because you're folding the half, so it would be a double. So we're going to double that, which is 8.
You are correct, and we have proof right there.
And so it would be so on. So it would be 4 is 16. 5 is 32.
And how do we move it down? I forgot.
Right over here on this bar, I'll move down
Okay.
for you a little
All right.
bit.
There we go. Okay.
Okay. 6 would be double that, so it would be 64. And 7, which is the amount of folds I did, would be 128 parts. And so also, if you can see, this one is 1, it's 1, 2. This one is 2 to the second power, which is also 2 times 2. And then this one would be 2 to the third power.
Here, I'll erase that for you. Okay.
2 to the third power, which is also 2 times 2 times 2. So it goes on like that, and that's how you would know that it would be around 128 folds.
All right, nicely
Very
done.
good.
So you've taken that 2 different ways right there. And do remember that we have phone tutors available until 5:30. Come on over here, because what we're going to do is, while we go to a break for just a moment, we're going to have you unfold this and see if you can verify and make sure that it is 128 folds or sections. And we'll be back with more right after this. Today we're at the Giorgio School, where home of the Dragons are, and today we're here to Well, this afternoon I've got Angela, a 5th grader at the Giorgio Elementary School. Well, the Giorgio School, right? Because I think you guys are K through 8, right? Mm-hmm. All right. How's 5th grade going?
Good.
All right. Let's do some math right here. The problem is, it says Angela, by chance, will buy new shoes in 11 days. What I'd like you to figure out is how many minutes that will be until you can get those. So how do you think you want to solve this problem? You have to wait 11 days to get these. And the problem is, how many minutes will that be?
First, I'm going to times 24 times 60 because there's 24 hours
In a day?
Yeah.
Okay. So if you're going 24, why are you going by 60?
Because there are 60 minutes in 1 hour.
Okay, so you can go ahead and do that. 24 times 60? So explain for me how you got these zeros, because there's some kids at home that are learning how to multiply right now.
0 times 4 is 0,
Okay,
and 0 times 2 is 0.
all right.
And my teacher taught me this. Cross out the 1, there are no more. Put the 0 right there.
Good,
6 times 4 is 24.
perfect.
Carry. 12 is 6 times 2 is 12, plus 2 is 14.
Okay,
Add that. 0, 4, 4, 1.
so we have 1,440, and what is that?
That's 1 day.
That's 1 day, right? So
Then you
that's the
go-
number of minutes in 1 day? Mm-hmm. Okay, so now what do we need to do? Yeah, let's get the eraser.
1,440 times 11.
And the 11 is what again?
The 11 days.
Right.
1 times 0, 1. 0.
Okay, you caught yourself there, huh?
1 times 4 is 4. 1 times 4 is 4.
All right.
And 1 times 1 is 1. And then cross out that. 0 right here. 1 times 0, 0. 1 times 4. 1 times 4 again. And 1 times 1. Add that. 0, 4, 8, 5, 1.
All right, so what is that final answer?
15,840
15,840 what?
minutes.
Do you think you could actually wait 15,840 minutes to get new shoes?
Yeah.
Oh, good, because you're going to have to. Nicely done. And once again, we do have phone tutors available until 5:30 this afternoon. Phone numbers are on the bottom of your screen periodically throughout the program. We're going to head out one more time to Bill L. Williams, home of the Pioneers, and visit with Marylou.
Thanks, Mike. We're back live at Bill L. Williams Elementary, the ACES After School program, and I have another guest with us. Why don't you let everybody know your name and what grade you're in?
Hi, I'm Aubrey and I'm in the 5th grade.
And Aubrey, what is the best thing about 5th grade?
Honestly, I think it's music because I really like singing.
Oh, very good. Okay, so, but obviously another subject hopefully is math that you like. And we have a math problem behind us. Okay, so here we have word problems. We just got done with our fractions and decimals and percents, but yet again here I'm looking and, oh, we do have a fraction in this word problem, huh? Okay, so let's see. It says Allie has 2 vegetable pizzas that she cuts into eighths. How many 1/8 size pizzas does she have? How do we solve this, Aubrey?
Well, since you have 2 vegetable pizzas, it would be 2 of these rectangles. And since she's cutting it into eighths, you cut it into eighths. So 1, 2, 3. And then you do it on the other one. And so pretty much I have 8 here and 8 here, which together would make 16. But to do the problem, it would be 2 divided by 1/8, which equals 2 times 8, which equals 16.
So you could get it 2 different ways. Yes. Here you gave us a picture, correct?
Yes.
And then we know that you take your 2 and you broke into 8 pieces and you took the other and broke into 8. So we have like repeated addition, correct? Yes. Because that's what multiplication is, it's just repeated addition. So again, did everybody see how we did this? Yes. Okay, so again, the first thing we do is we can draw a picture, create a picture, correct? Of what we're doing. We're taking our total, our whole pieces, and we're breaking into what it's telling us by our fractions. So we're dividing it and we're coming up with our total. Your job, again, we have a recorder, yes? Each group has a recorder, and Aubrey, you're going to be making sure they're doing this right. Yes. This is your problem that you're going to be solving as a group, okay? So a baker has 6 loaves of bread. Each loaf weighs 1 pound. He cuts each loaf into thirds. How many 1/3 pound loaves of bread does the chef now have? Now, Aubrey knows what the answer is, and she's going to be walking around and seeing how you guys are doing. Again, we want to see a picture of it, okay? Do a diagram, and then show us the equation as well. And you guys, again, are working as a group. Ready? Mm-hmm. Go. All right, Aubrey. Your job is to walk around and see how they're doing, okay? All right, go. So, how's this group doing? Are they starting off right?
Yeah.
Yeah? Okay. Let's go over this group over here. Let's see how they're doing. Okay, what are we doing over here?
We're drawing 6 loaves.
Okay, and what are we doing with each loaf?
We're cutting them into thirds.
Aubrey, are they doing it correct?
Yes.
Okay, let's go over here and check out these other 2 groups. You guys keep working. You're doing a good job. How are we doing over here? How are they doing, Aubrey? What do you think?
They figured out the answer.
They did. Okay, real quick, let's look at our last group. We'll come back to you guys. How are they doing?
So far, so good.
Okay, keep going, guys. You're doing a good job. Okay, let's go back to this group. Explain to Aubrey what you did.
Since there are 6 loaves of bread, I drew 6 boxes, and since they cut them into 1/3, I cut them into thirds. And so, since there are 6 boxes, I put 6 divided by 1/3 because they cut them into 1/3, and so 6 times 3 equals 18.
Okay, and you figured that out, yes? Yes. Okay, how are we doing over here? What did we get, guys?
18.
Yes, they got 18. That group over there?
18.
18, yes? Okay, now here's my question to you. Do you really need a diagram to figure this out?
No.
No, we don't. Can I look at this and go automatically? We have 6, right? And we have, where's our 1/3? And we have our 1/3, yes? So we know that 6 divided by 1/3 is the same as 6 what? Times what?
Times 3.
Times 3, yes?
Yes.
Okay, here you go. I want everybody to do this real quick. Everybody have a pen? You're going to do this without a diagram. Okay? Give me a number, a whole number.
10.
10. Give me a fraction.
2/3.
Oh, give me with 1.
Oh, with 1. Okay.
1 over.
6.
Go, solve that. Solve that. What do you think that's going to be? Aubrey, do you know the answer? All right, hold up your paper when you have your answer real quick. Let me see, real high, real high. Everybody yell out the answer. What is it?
60!
Aubrey, is that correct? Yes. All right, good job today. Good job today. Hey, remember that when we're doing division, it's really also what? Is it also multiplication? Yes. Very good. All right, we're going to send it back to the studio.
Thank you for that, Mary Lou. Nicely done with the students out at Bill L. Williams Elementary School. Now, you showed us 2 ways on how you got the 128 sections, different parts, when you did the folds. So you unfolded the paper, and how did you count these?
Well, instead of counting each one would take a long time, I did the length and the height, and then I multiplied those.
And what were the 2 numbers you got? So when you counted across the length, what was that?
16.
Okay, and then the width of the paper was?
8.
All right, so you had 16 times 8, and you multiplied the length times width, you get the whole area.
Yeah.
So 16 times 8 was what?
128.
There you go. So you got all of those completed, and you verified that you had 128 different parts
Yes.
on here. Now, what I'd like you to do is on each one of the 128 parts, I would like you to draw me. I'm only kidding. You don't have to do anything in these 128 parts, because what I'm going to do is I'm going to put you back to work again. You ready?
Oh, yeah.
All right, back over to the board. This is something that you are starting in class right now. This has to do with interest. All right, so over to the board. And we're going to do a simple interest problem first, all right? So Susie's going to work with you and kind of get you through this with simple interest. So first, let's just put P for principal. And Julie, that's going to be the amount of money that you put into the bank. So what amount of money would you like to put into the bank?
Let's do $250.
$250. And Susie, let's put R for rate. And you can choose the interest rate.
Well,
Since you're going to be working the problem, I'll let you gauge the difficulty of what you want to do here.
okay. So let's choose 4%. The
All right,
interest rate
and we'll
is
do this
usually-
first for 1 year.
Okay.
All right, so go ahead, ladies.
Okay, now you said before here that you had already done percent problems?
Yes.
Okay, so if you were doing 4% of 250, how would you do it?
Well, you change this to a decimal,
Right?
so it would be 0.4. Get rid of this. And then I believe you'd multiply this times that.
Right. Okay, go ahead and try it. And hopefully your 5 will look better than mine. Good.
So the interest rate be $10.
Okay, so I'm just going to add a little bit to the vocabulary. The interest rate is actually 4%, but the interest earned is
Yeah.
$10. So if you earned $10 interest, and this is correct, how much money would you have in the bank?
$260.
Very good. You do really well in your head. Okay, so
All right.
now should we?
Well, we're going to pause on that for a moment because I think
Okay.
we have Nathaniel on the line right now. Nope, no Nathaniel right now? Yeah, we've got Nathaniel. All right. Nathaniel, how are you today?
I'm good.
And what grade are you in, 7th or 8th grade?
8th grade.
8th grade. As soon as you're ready, let's hear the math problem that you're working on.
We don't
I'm
need
ready.
All right,
Okay.
go for it. Come on over, Julie, and take a break for a minute.
Huh?
You go ahead, Nathaniel, as soon as you're ready.
Well, I got a new one. It's 8x plus 3 minus 5x equals 2 minus 1 plus 3x. Wait, no, plus 4x.
All right, so read it one more time so Susie can get it written down for you.
Okay, 8x plus 3 minus 5x equals 2 minus 1 plus 4x.
Okay, and just to make sure before we go on, you have 2 and 1 have no x's with them, right?
Yes,
They're just
don't
by
have x's.
themselves. Okay, so what do you think we need to do first?
Right here.
To combine like terms.
Right, so I'm gonna put this and this together, and I'm gonna put this and this together. Does that make sense? Would you do the same thing?
Yeah.
Okay, read
You
me the
put-
new problem then. So
Huh?
8x minus 5x is?
3x.
Good, so now I have 3x plus 3, need to bring that down. And on this side, I have positive 2 and negative 1, or you can think 2 minus 1, what's that?
3 minus 1?
Mm-hmm.
2.
I'm sorry, 2 minus 1,
1.
1. Okay, so we have 1 plus 4x. Okay, does that look right to you?
1 plus 4x?
Yeah.
Uh,
Do you,
yeah.
I lost it again.
Oh, hold on a second there, sister. Let's go back. There we go.
There we go. All right. Now we have x's on both sides. So what do you think we should do?
You divide, or you subtract on the other side for the smallest one.
Yeah, I like to subtract the smaller amount of x's because then I don't have negatives. So I would subtract 3x from both sides. Does that
Okay.
sound good to you?
Yeah.
Okay. So we're going to subtract 3x from both sides of the equation. All right. And then
Okay.
this goes out, and I have positive 3 on the left side. And what do I have on the right side?
The x, or the 1 plus x,
Excellent. 1 plus
or x
x.
plus 1.
Okay. All right. 1 plus x, x plus 1, the same thing. Okay. Now I bet you know what to do.
You just subtract the 1 and the 3. You subtract the 1 on both sides, and then you divide, and then x equals 2.
Okay. 2 equals x. All right.
So 2
And what-
equals x.
That's right. What could we do to check our answer?
You can substitute.
Right. So I'd have 8 times 2 is 16, and 16 plus 3 minus 5 times 2 is 10 equals 2 minus 1 plus 4 times 2 is 8. So 16 plus 3 is 19, minus 10 is 9, and then 2 minus 1 is 1, and 1 plus 8 is 9. So it worked out.
9 equals 9.
There
Okay.
you go. So there we verified that x is equal to 2. Great phone call right there, Nathaniel. Hey, we do have phone tutors available until 5:30 this afternoon. And you, young lady, were working on that problem because I know in 6th grade you started working on these equations and you were able to verify the same answer right there. All right. Head down and back over to the board. I've got a little bit of an addition to the problem you were working on. So you had initially $250. So let's go ahead and put the 250 up on the side at
Okay.
4%.
Okay, and you already had a really good answer, right?
And that was going to equal $10 in interest, which now gave you $260 total. So that's for 1 year. So that's simple interest, Julie. So now compound interest is when you take and you find the interest on that total now. So you're going to keep the same percent, the same rate. So now what would you gain if you had $260 in the bank?
I used to love to do this when I was a kid. I would go on and on and on. Very good. She knows what she's doing.
You would earn, well, you'd get $10.40, and that gets you a total of Oh, nope, that is not right.
So if you need to erase something, go ahead, because I can tell that you noticed something didn't seem to quite work there.
Yeah. I'm just missing one number.
No.
Yeah, there you go.
So, that would be your total.
That's excellent.
So now you've got $270.40. So if you went for 3 years, what would the next step be? What would you have to do to figure out how much you would have after 3 years?
You should start at
And
the top.
just go to the top.
So right now you have 270, 40, right?
Mm-hmm.
And so you want to do a rate on that 3 years. So you would do 0.12.
Well, that's thinking if you did all 3 years at the same time and it was simple interest, that's what you would do. But you're just going to do one more year. The third year is going to be one more year. So you only have to do them, just like what you did before.
I thought you said for another 4.
There you go. Now you don't even, I mean, you can go ahead and finish up working on that, but all I wanted to know is if you knew what the next step was, and taking that accumulated principal plus the interest for the first 2 years, multiplying it again times that third year with 4% interest, we'll go ahead and give you that final answer right there. So you can take, now you're gonna have to do a little rounding on that, so we'll come back to you in a minute.
Yeah.
But right now we're gonna head out one last time to the folks at Bill L. Williams Elementary and Marylou.
Actually, we have 4.
Thanks, Mike. We are back live at Bill L. Williams Elementary ACES After School Program with our last guest of the day. Why don't you go ahead and introduce yourself?
I'm Calissa from Bill L. Williams Elementary School, and I'm in 5th grade.
And Calissa, what's your favorite thing to do in 5th grade?
Math.
Yay! All right. So we got some math problems, right? Yes. Okay. So you and Aubrey are kind of doing the same thing in class, correct? Yes. And so let's kind of go back over what we did. Here we had 6 divided by 1/3. Again, how did we solve this? What did we do to solve that?
Well, we just rewrite it as multiplication 6 times, and then you flip this over 3/1, which equals 3.
Well, 6 times 3
Yes,
equals what?
18.
There you go. Equals 18. So again, I love the way you said that. We write 6, we keep our dividend the same, but our division sign we changed to?
Multiplication.
And because we did that, we really flipped this, and that's called a reciprocal, right? So we flipped it. Okay, so what if we have all fractions? So let's take this knowledge, okay, and let's change it to all fractions. So here I have 2/3 divided by, let's say 5/6. So how do we solve this?
Well,
Are we going to keep the 2/3?
yes.
Okay. And we're going to change division to?
Multiplication.
Got it. And what are we going to do to that 5/6?
We're gonna
We're going to flip
Flip
it,
it over.
right? There you go. 6/5.
5.
And now all we have to do is what?
Multiply 2 times 6, which equals 12.
And multiply our denominators, right?
Yes.
Which is 15. So our answer is 12/15. Yes?
Yes.
Okay, we actually can simplify this. And I don't know if you guys are working on simplifying, but we know that 3 can go into both numbers. So by simplifying, remember we're going to divide them both by a common number. So let's divide those by 3. What's 12 divided by 3?
Is 4.
And what is 15 divided by 3?
Equals 5.
There you go. So our answer, we're going to start back over here. We have 2 over 3 divided by 5 over 6, which is 2 over 3 multiplied by 6 over 5, equals 12 over 15, which is the same as 4 over
5.
Wow, that's a big one, huh?
Yes.
Okay, are you guys all ready to go? Yeah. Got your pens? Okay, ready? Write a fraction for me. Write your division. Write another fraction. All right, guys, there you go. There's your problem. We have 5 over 6 divided by 3 over 4. Again, look here on what she did, okay, to help you out. You ready to walk around? Let's see how everybody's doing. Let's start this way, okay? Let's see if they're doing it right. So the first thing they need to do is to do what? Are we going to keep this the same? Is the first number going to stay the same? Yes. What's going to happen to the division sign? Tell them what are they going to do with the division sign?
You're going to flip it over to multiplication.
Very good. And then what happens to the second number, our divisor?
Flip it.
We're going to flip it. Good job. They're on the right track. So let's go on over here. Oh. Let's see. Does she have it all right? 5, 6 times 3/4. Yes?
No.
Yeah, yep. Oh, what did she forget to do right here?
Flip it over.
You forgot to flip that. So make sure you flip that. Good job. How are we doing over here? Oh, did he flip it?
Yes.
Yes? Okay. 5 times 4, is that 20?
Yes.
Yes. 6 times 3, is that 18?
Yes.
Awesome job. See if you could simplify that. Okay. Let's see. Do we have some more? Wow. Oh, love. That's perfect. Yes, yes, yes. Can I take yours for a minute? Good job. Good job. Let's see. How we doing?
Good.
How many of us have 20 over 18? Raise your hand if you have 20 over 18. Yes? 20 over 18? Yes? Okay, come on back up here. 20 over 18. How many of you simplified it down to what?
1/9.
How many of you have 1 1/9? Simplified it all the way down. Awesome. Good job. Let me have all 3 of our guests up here today. Good job today. All right, so we covered our fractions and our decimals and our percents, and then we did dividing, right? And then with whole numbers and fractions, and then we even took another step with dividing with 2 fractions. A lot of work today, yes? Well, I want to thank you all 3. You guys have been absolutely wonderful today. And again, thank you to your school for letting us come. It's always a pleasure coming. And thank you guys out there too for doing the work today. You guys have done a great job. And that is it from Bill L. Williams today. And thank you again, and we're going to send it back to the studio.
All right, thanks for that, Mary Lou. Hey, just a reminder, we do have phone tutors available until 5:30 this afternoon. Julie has done some excellent work this afternoon, working with the paper folds and things like that, and then working on simple interest, and then moving all the way into compound interest as well. So you've got your feet wet with that. So when you get into that in the regular classroom, hopefully you remember a little bit of what you did with Suzy here. All right. I'd like you to draw one of the names from the students that worked on air today and find out who's going to a CSUB sporting event of their choice.
Alondra.
Alondra from Bill L. Williams, a 6th grade student, so congratulations to Alondra. Going to any CSUB athletic event of her choice, so congratulations on that. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.